Alright guys, today we're going to solve quadratic equations using radicals. Now, let's do a quick review of some terms. First of all, or some things with radicals. Radical is some sort of root like that. Now, right now we're going to be using square roots, but later on this year we'll be talking about cube roots and eighth roots, and oh man, it's going to be so much fun. But for right now, we're going to focus on square roots. Now, with square roots, let's review how to simplify. To simplify, let's do a couple of these. Let's do root 4, root 12, and root 72. Root 4, hopefully you all know, that is a perfect square, so root 4 is straight up 2. Now, the reason why, though, is because radical means what number times itself is 4. Well, if you break, I like to make a tree. 2 times 2 is 4. What number times itself is 4? It's 2. But 12 is not a perfect square. Still, we're going to do the tree. We're going to do 3 times 4. 4 breaks down to 2 and 2. So, in order to get out of radical land, you need a buddy. In this case, there's a pair of 2's, so a 2 comes out. Just like it did here, right? 2 2's came out. However, this 3 did not have a buddy. Whoa. So unfortunately, sadly for this guy, 3 got left behind. So root 12 breaks down to 2 root 3. Now, this is the exact answer. If you were to put into your calculator root 12 and 2 root 3, you would get the same decimal grossness. The problem is that decimal never ends. So 72. Let's make a tree. What multiplies a 72? How about 9 times 8? I bet most of you are thinking that. And then 9 breaks down to 3 and 3. 8 breaks down to 2 and 4. 4 breaks down to 2 and 2. So break it down as far as you can. Remember, when we're simplifying radicals, you only look at the end. So who's got a buddy? Pair of 3's, so a 3 comes out. And a pair of 2's. There's 2 sets of buddies here. A 2 comes out. But this 2 here, that other end, that 2 did not get a buddy. He stays inside the radical land. So we can multiply things that are outside. This is going to be 6 root 2. Alright, quick review on simplifying with radicals. Next thing I want to talk about are there's 2 general rules associated with radicals that you need to know for right now. The first one is the square root of a times b is equal to root a times root b. We actually kind of demonstrated that up here. Right, root 12 is the same thing as root 3 times 4. And then the square root of 3 is root 3, square root of 4 is 2. Anyways, then the other rule that I need you to know is the square root of a divided by b is root a over root b. So, let's talk about this first rule here. Let's do an example. How about 2 root 6 times 8 root 10. Now, just like we split it up here, root 3 times 4, backwards also works. Root a times root b can be multiplied together. So, looking here. First thing, we're going to multiply our regular stuff. 2 and 8 are just our regular numbers. 2 times 8, of course, is 16. But then we can also go and multiply the radicals. Root 6 times root 10 is root 60. So what we have here is 16 times the square root of 60, which, are we done? Not quite. We gotta see if 60 can be reduced. Now, you could go and make a tree with 60. What multiplies a 60? Oh yeah, how about 6 and 10? That's what we did to get it. All right, 6 and 10, 2 and 3. 10 breaks down to 2 and 5. So 2 has got a buddy, so he comes out. The thing is, don't forget about our 16. our 16 is already outside, times, and then whatever comes out of 16. 16 times 2. Now this time we got 3 and we got 5 got left behind in radical land. Neither of them had buddies, so that's 3 times 5. Both inside of radical land. So our final answer here is 32 root 15. That's what you should have got there. Another demonstration of this rule, our quotient rule, is this. The square root of 25 divided by 49. Well, square root of a fraction is square root of the top by the square root of the bottom. Fortunately for us, these are both perfect squares. Root 25 is 5. Root 49 is 7. So that would be your final answer. One other thing that you may have seen before, but we kind of need to be good at, is called rationalizing the denominator. Now with rationalizing the denominator, turns out it's not cool. Let's say we had root 3/5. Well, that would simplify to root 3 divided by root 5. Neither of them are perfect squares, and it turns out that it's not cool to have a radical in the denominator. In the math world, that's just bad manners, yo. So, in order to fix that, we got to get this root 5 out. Root 3 is fine. The numerator is fine to have a radical. It's the denominator that's not allowed to have. So what we're going to do is we're going to get this so that it's not a radical. The way we're going to do it is we're going to multiply both the top and bottom by this root 5. This would be root 5 and root 5. The reason why, anything divided by itself is 1, and anything times 1 keeps the same value. So we're not changing the value at all. The only thing that we're going to do here is change the cosmetics. So root 3 times root 5 is root 15 over root 5 times root 5 is root 25, which is, hopefully you all know it's 5. Now, if you were to take your calculator, do the square root of 3/5 and do the square root of 15, or root 15 divided by 5, you'll see it comes out to be the same thing. All right, so that's a quick review about radicals. But how are we going to use these radicals? We're going to use radicals to solve. And we got 3 examples here. Start off with a pretty simple one. The first one is x squared is equal to 9. Now, the whole thing about x squared is equal to 9 is we're trying to figure out what number times itself is 9, which most of you are thinking 3. You're absolutely right. 3 times itself is 9. However, is there anything else when you multiply that will give you 9? Some of you might have come up with -3. So here's a little thing I'm going to tell you. The enemy of squared is square root. So just like we saw, whatever you do on one side, you got to do to both sides. Square root undoes squared, and we're left with just x. But then the square root of 9, of course, is 3. But here's the thing. We're going to put a plus or minus in front of the root 9 to get our final answer of x is equal to plus or minus 3. Guys, that's going to be important. Here's what I need you to know. If you use a square root to solve, you must put plus or minus by the answer. By the answer. You got to put a plus or minus. Whenever you use a square root, you're going to put a plus or minus. Wait a second, Smith. Way back here at the beginning when we were simplifying, you never had us put a plus or minus in front. You're right. Here's the thing though. When we're simplifying, to keep it simple, we're just going to make a tree and just come up with the equivalent value. That's it. We keep it simple. But if you solve, you have to use a plus or minus if you use a square root. Let's show another example of this. How about x minus 3 quantity squared is equal to 18. Alright, now the first thing here is we got to get rid of this squared. In order to get rid of the squared, what's the enemy of squared? Square root. So now we're left with x minus 3 is equal to plus or minus the square root of 18. Now 18, we make a tree, we get 9 and 2, 3 and 3, and we get 3 root 2. Alright, but now I don't care about what x minus 3 is, I want to know what x is. So we're going to add 3 to both sides. And what we got here is x equals. Now, are these like terms? Can I add them? No. 3 root 2 is different than just a regular 3, so our answer is going to be 3 plus or minus 3 root 2. There are actually two answers here. One of them is 3 plus root 2. The other one is 3 minus root 2. There's two different values here. Alright, and I got one more example for you. Our last one is going to be 2x squared plus 1 is equal to 17. Now before we go ahead and do this problem, I want to remind you of, y'all remember our order of operations PEMDAS? Please excuse my dear Aunt Sally. Or parentheses exponents. Multiplication and division at the same time, they have the same rank, and addition and subtraction at the same time, they have the same rank. Well, I don't know if you knew this, when you solve, you're doing the PEMDAS backwards. So, in this case, what would be the first thing that we would do? We would subtract 1 from both sides. Addition, subtraction, check. So, now we're left with 2x squared is equal to 16. Is there any multiplication or division to get rid of? Yeah, we got to get rid of that 2. Check. We're going to divide by 2 on both sides. And now we're left with x squared is equal to 16 divided by 2 is 8. So the next thing we need to check is exponents. Is there an exponent here? Sure enough. Square root is the enemy of squared, or the inverse operation. You're left with x equals plus or minus, then figure out what root 8 is. 8 breaks down to 4 and 2, 2 and 2, plus or minus 2 root 2. So our answer would be plus or minus 2 root 2. Wait a second, Smith. On the previous example, there was a minus. How come we didn't get rid of addition and subtraction first? Because it was locked up inside parentheses with the squared, we couldn't get rid of it. The squared locks it up. We have to get rid of the exponent first. Then the only thing we have is addition and subtraction, so then we get rid of it. Probably practice some more in class. Smith out!